Today we have seen basics of organic chemistry, hydrocarbons, classification, and nomenclature. What do you mean by nomenclature? Nomenclature, which means naming. We are supposed to identify the name of that compound which is existed in organic or biological fluids or biological system. Okay, then in botany we have nomenclature, which is of binomial nomenclature, which has two terms, binomial, and which is described by Corollas Linnaeus. And then geology also, we have that method of nomenclature. It's like naming plant or animal. Okay, next. So if in biology, I'll say, let us recall Mangifera indica, Mangifera indica. Next, Curcuma longa, Izadi recta indica. Here indica, which significantly tells us the geography of that plant or animal, and mangifera, which refers to mango. Mango is our national fruit. Next, Curcuma longa, which is a tuber which turmeric, and Azadi recta indica, this is neem. So that these are three examples. Then when we talk about this is our compound of interest, or this is our candidate, then we'll talk about one is a long chain of carbons, hydrocarbon, long chain hydrocarbon, saturated, and the terminal group, which means last one, terminal group is of OH. Here you have to number it 1, 2, 3, 4, 5, so that which is a 5 carbon long chain saturated hydrocarbon, so that pentane. But fifth carbon or terminal carbon replaced or substituted by OH group, so that pentol, or else 5 hydroxy pentane. This is the long chain, that is parent chain, and this is a group which called as functional group. Okay, functional group. This functional group gives chemical properties and physical properties to the parent compound, so that functional groups or functionalities are deciding factors to behavior of that compound. Physical behavior, chemical behavior, or physical properties and the chemical properties, and they will tell about their melting point, boiling point, and their existence or their conformations. All these things are most of the time depend on the functional groups and functional group properties. So that here we have to discuss about some more functional groups. Most of the times when it is a linear compound and carbocyclic compound, then aromatic compound, then these are the three types of compounds. They have shown in multiple areas of our biology. Saturated linear compounds like paraffins, and those of fatty acids. Fatty acids, they are end up with the functional group acid, which is C double bond O and OH. This is the functional group. They are under linear saturated paraffins or linear saturated hydrocarbons. And then carbocyclic compounds, they are all of cyclobutane, cyclopentane, cyclohexane, but 4, pent 5, and hex 6. And the third category is of having delocalized electron cloud. Which disperse throughout the cycle or throughout the cyclic structure. They shown or they exhibit aromaticity by the localization conjugated pi bonds or alternative pi bonds. Then these are the three types of compounds. One is linear, and another one is carbocyclics, and the third one is aromatic compounds. In this aromatic compounds also we have seen some of them having a heteroatom such as nitrogen, oxygen, sulfur, and these are the compounds. They are called as heterocyclics. What are they? Heterocyclics. And then some of them are fused with the other ring structure. They are called as fused ring system. Yeah, fused ring systems. Which is naphthalene, which is indole, which is beta-lactam. These are scaffolds are pharmacophore units of medicinal agents or medicines to give biological activity in the biological system. Here you can see fused systems with heteroatoms. They are the biosource for indole or tryptophan, indole, acetic acid, or else catechol, catechols. They are dopamine, decarboxy, amine, catecholamines, Here, acids, amines, ols, alls. Let us take example. C2H5OH, ethanol, ethanol. In case of aromatic ring, phenol. Methyl ethane, toluene, acidic groups, carboxylic acid, amine, primary amine, benzyamine, so there are carbonyl compounds, acid, aldehyde, ketone, amide, anhydride. So all these are comes under carbonyl compounds. Okay, so this is how we have to categorize all the nomenclature. There is a parent chain and there is a functional group. Which functional group? which is of alcohol, acid, aldehyde, ketone, carbamide, and all these things. Then fused ring systems, cyclic systems, cyclic structures, aromatic structures, and aromatic naming or anything. That's how we have named the organic compound. So these are the most of the times these are the examples that you can see in our biological system. And some more examples I'll say they are like catechylamine, which is dopamine, tryptophan, serotonin, and gamma aminobutyric acid, amino butyric acid, glyceraldehyde, polyols like glucose, aldoses and ketones. Amino acids, peptides or amides, and fatty acids, saturated, unsaturated. This is the basic biochemistry or organic chemistry, whatever the thing it is. These are the basic things. So what you have to do is that to refer any one of the standard book that you want to learn, and then take a notebook and make your own notes and draw all the structures, functional groups, all the functional groups, and the regarding examples. And remember the biological scaffold or biological pharmacophore that already exists in your physiology, and then it will be easy to remember, or it will be easy to recall. Mommy. Thank you.